Let A is equal to r minus 3 and B is equal to r minus 1. Consider the function f from A to B defined by f of x is equal to x minus 2 upon x minus 3. Is f 1 to 1 and on to? Justify your answer. Let's check 1 to 1. Let's use the definition. For x1 and x2 belongs to the domain f of x1 is equal to f of x2 implies x1 is equal to x2. So let us consider here. Let x1 comma x2 belongs to the set A, which is the domain of the function, such that their images are equal. Say f of x1 is equal to f of x2. So that is x1 minus 2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. So for the cross multiplication, x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. So which implies x1 x2 minus 2x2 minus 3x1 and plus 6 is equal to x1 x2 minus 2x1 minus 3x2 plus 6. So we may cancel here x1 x2 on both the sides with the same sign and plus 6 on both the sides, and here we can write 3 times x1 we can bring here. So 3x1 minus 2x1 on the right side, and the right side let us bring here 3x2. So 3x2 minus 2x2, so which implies here x2 is equal to x1. So which gives the definition for f of x1 is equal to f of x1 is equal to f of x2. We got x2 is equal to x1, and therefore we can say that f is 1 to 1. Now let's check on to. So the definition of on to, for y belongs to codomain, there exists at least one x belongs to domain such that f of x is equal to y. So let's use this definition to check whether the given function is onto or not. Let y is equal to, or let us consider y belongs to the codomain. The codomain is given B, which is equal to r minus 1. So that let f of x is equal to y, where x belongs to the domain A, so that given function x minus 2 upon x minus 3 x minus 2 upon x minus 3 is equal to y. On cross multiplication, we have x minus 2 is equal to y times of x minus 3, or we can write x minus 2 is equal to xy minus 3y, or we can write x minus xy is equal to 2 minus 3y, or we can take x common and we can write x of 1 minus y is equal to 2 minus 3y, or x is equal to 2 minus 3y upon 1 minus y. And since y is not equal to 1, so we can say for every y belongs to B where y is not equal to 1, there exists x is equal to 2 minus 3y upon 1 minus y, which can belongs to a such that now we need to consider f of x. Consider f of x, which is equal to f of 2 minus 3y upon 1 minus y, which is equal to 2 minus 3y upon 2y minus 3y upon 1 minus 2 minus 2 upon 2 minus 3y upon 1 minus y minus 3, substituting in the function, so that simplification 2 minus 3y minus 2 times of 1 minus y upon 2 minus 3y minus 3 times of 1 minus y, and here upon 1 minus y and here upon 1 minus y may cancel, so we can cancel these two terms, which is equal to 2 minus 3y minus 2 plus 2y upon 2 minus 3y and minus 3 plus 3y. So we may cancel the terms. Plus 2 and minus 2 get cancelled in the numerator, and plus 3y and minus 3y gets cancelled in the denominator, and so we have, so which is equal to minus 3y plus 2y, that is negative y, upon minus 3 plus 2 is negative 1, so which is equal to 1. Therefore we can say that there exists x is equal to 2 minus 3y upon 1 minus y, such that f of x is equal to y, and hence we can say f is onto. So therefore we can conclude that the given function is both 1 to 1 and onto.